Hey guys, today we're going to be doing an LS430 2000 to 2003. This one is using the automatic gearbox, but it's part of our new universal base harness. So let's get into it. Right, so as I said, this is a LS430 2000 to 2003. That means it came with the 5-speed automatic gearbox. Now, this harness in particular is going to be using the 5-speed automatic gearbox that came behind the original engine, but obviously it is a completely brand new harness built to bring the ECU and the fuse box inside the vehicle rather than the engine bay where the ECU used to live on the original LS430. Right, so now this is our new 3UZ harness that basically allows it to be used with both an auto and a manual setup, and we'll go through that as part of the layout. But first of all, we're going to run through the build process of this harness, show you exactly what it looks like underneath that heat shrink, and show you all of these sub harnesses that are part of this harness. So let's do that now. I'll be back in a second. Alright, so there you go. Now you can see exactly what makes up this entire harness. So what we're going to do today is, same as usual, we're going to go through the layout, show you exactly where everything goes, explain the new universal base harness, and then what we'll do is we'll go into the testing. That'll be with the ignition on and obviously with the engine running as well. So those are the three things that we're going to do in total. To start with, let's get on with the layout of the harness, and we're going to start right here at the ECU side. Okay, so nice and simple as per usual. ECU, you've got 1, 2, 3 plugs that go over to the actual engine harness itself. We then have 1, 2 body plugs, and they make their way to the fuse box over there. Now you can ignore this one. This is just for our testing purposes. I'm using an IS200 dash so I can have gear position. So when we come to test the gear position, I can use that. Right. Then lastly, out of this one, you have the pedal harness. So again, nice and all labeled for you guys. Pedal. Let's get that one around, and pedal over there, as you can see. So again, nicely labeled. In this case, it is a 2-meter long harness. You can see it snaking around here, and it's going over to the pedal that we are supplying the customer to use with this particular harness. So again, all straightforward, plugs in and all labeled for you guys. Right, so moving on to the actual engine harness itself. Now you'll see we've got a breakout point over there, and if you look underneath there, follow my finger, it runs around and it goes to the fuse box over there. So this is all the wires that come from the engine harness that need to go to the fuse box. So it's supplying things like injectors and coils, power, starter solenoid, etc. Okay. What you'll notice that's new is this little 3-pin plug over here, and is labeled as manual. So as I said, this harness now is a universal base harness. It can be used both with an auto and a manual application. So you no longer need to have one specifically for your gearbox. And this is one of the side effects of that. So basically what's in here is the possibility to add a reverse switch. So there's 12 volts in here. Sorry, not 12 volts, but there's a reverse light, and then there's 2 wires for a Hall effect style speed sensor to supply the ground and the signal. So the way the Toyota do it is they run the ground and the signal to the cluster, so they avoid ground loops in terms of the speed signal. So we've replicated that here in its entirety. So that's what this is for. In this particular case, as he's auto, this is obviously going to just be left undone. Right, moving along from there, you'll see the harness moves down. We go to our usual grommet with the SCL epoxy lined heat shrink on there. So once the customer's happy with where this location is, he can then seal that down. Moving along there, and then we get to our T-piece molded boot at the back of the engine. Now again, it's splitting going that way and going that way over there. We're going to start going here, and then we'll come back and we'll go through all of the stuff at the back here. So first in the brake side here, you can see is ignition left. So that goes over to our 8-pin DTM plug over there, which then goes to all of our coil plugs over there. So again, this is completely unpluggable. Just makes life easier for you guys. Obviously, if you want to change your spark plugs, you can just unplug that one plug over there, remove all your coils in one go, and you don't have to individually unplug all 4. Also, that helps with these because they do have a finite lifespan in terms of how many times they can be connected and disconnected. And they're a bit of a pain in the rectum to actually get off as well. So nice neat little trick that you can do there. Obviously, the other upside is that if you guys ever wanted to use this with a manual gearbox and switch to an aftermarket ECU, well, you can go with any coil that you so desire. And obviously, again, you can just unplug this and plug in a new coil harness. Right, as you can see, the harness moves along there, and we break out here close to the cam sensor. Now, this one is labeled as VVL. It's a cam sensor that's only measuring the inlet cam, and it's designed to keep an eye on what the VVT-i is doing. So whatever the ECU commands, that will then measure if the cam is advancing and retarding accordingly. Again, the harness moves along here, and we can break out here by injector number 1. So again, sorry, this is injector 1, 3, 5, and 7. This is the left bank, that's the right bank. So you always look from the driver's point of view. And on the left bank, or bank 1 is also known as well, you've got the odd numbers, so 1, 3, 5, and 7. The right bank, or bank 2, is on that side. And obviously you have, again, 2, 4, 6, and 8. So that's all the even numbers on there. Right, just get that out of the way. So where it breaks out here at the front, first thing we're going to go through is the oil control valve. So again, that is all labeled for you as OCV for oil control valve. This is what actually rotates the cam, and the ECU commands that solenoid to operate to advance and retard the cam accordingly. The harness then moves along there. You can have a little mounting point here to keep it in order. And then we come down here and we go to our cam sensor at the front. Now, just be aware on the 1UZ and 3UZ VVT-i, there are 3 cam sensors. You have one at the front here that is used for engine position. You have the VVL and the VVR, and those are just monitoring the inlet cams to make sure that whatever the ECU is commanding with the oil control valve is being achieved. Okay. Then the harness comes down here, and then you've got 2 mounting points, or should I say 2 holding points, if you will, that are just here and here. So again, you should have your original clips. Just ignore mine. It's just something that I can easily access to put the harness in here to show you guys where to clip it down to. Comes down over here, and then it's going to break out into 3 sections now over here. So you can see there we've got our very thin section. That is going to go down and make its way to our oil pressure switch. We then have the other section that's coming through here, and as you can see, they just sort of push down through there, make their way through the bottom. And the thicker one is going to be your crank sensor. Again, everything is labeled, so don't stress. You should say CRK there for crank. The next section that breaks out can also be put through here and down through here if you want, or it can be brought over the top. Really makes no odds or sods. But basically that comes down and that goes to your Lambda sensor for the left bank, right? Now, as you're aware, if you've seen a standard harness, they do actually bring it through there. We bring it down through here. That avoids any type of heat. So you guys aren't required then to obviously fit that little heat shield that goes over there. This was just a better option. Makes your guys' life easier. You can run this all on the bottom here. It's nowhere near the exhaust, and you don't have to worry about the connectors and anything getting a load of heat and going brittle over time. Okay. Right, so just another one as well. The reason we've broken off the oil pressure here is obviously if you have an LS430 2000-2003, this is the kind of oil filter housing you have. But if you had a GS or an SC, because you needed to use a front sump instead of like the mid/rear sump, this would obviously be on the other side there. And the fact that it breaks out over here means you can also run it through there and actually come out here and go to the switch over there. So you have no restriction on oil filter housing that you can use with this harness. Okay. Right, so coming back along here, and then we're going to end up at the back of the engine of the boot again. So Quite a lot going on here now with the new base harness. So let's start with the easy stuff. So again, we have our injector harness. So that's our injector harness that goes underneath the inlet over here, mounting point over there, and then it pops out to our injectors on either side. So you can see these are all labeled 1, 3, 5, and 7. Hopefully that focuses there. Yep. And also then pops out on the other side for the other injectors over there. So again, you've got 8, 6, 4, and 2 over there. So that's boom, boom, boom. Again, so they come through over there. They now form part of the inlet manifold and they're not a separate section. Okay. Right, so again, nice and easy for you guys. If you guys want to remove the inlet manifold, instead of having to actually unplug all the injectors, you can literally just unplug this injector harness, and that means you can remove the entire inlet manifold without having to unplug the injectors. Again, same principle applies. These standard connectors, due to the terminals and the plastics, they have a limited sort of connect and disconnect life cycle, whereas these DTM connectors have a much longer life cycle to be connected and disconnected. So that's just helping to save your connectors. And obviously, if you wanted to go with aftermarket management, well, you can change injectors. Phone us up, we'll make you a new sub harness that goes to whatever injector connector that you require. Also built into that is your vacuum solenoid valve for the ACIS. So it's somewhere about here underneath. And obviously that just plugs straight in over there. Now then, that is what controls your ACIS system, or this valve over here, the vacuum system with the big black tank underneath there. Now, while you've got that off to obviously put that harness in, as well as the other one that goes to the starter knock, which we'll get to in a minute, that's a good time to test that solenoid. So if you've got, just supply 12 volts and ground, it is polarity sensitive. So if you try one way, it doesn't work, swap the wires around the other way. You just want to hear a click from it. If it clicks, that means everything is good. Put everything back together, bolt it all on when you're done. If it doesn't click, now's the time to change it, because as you can imagine, it's all the way under the inlet manifold. You don't want to have to be taking this off again once you've got everything in the vehicle and you get it to start, because obviously it's difficult to tell. It's only when you start it up and you see that valve move down that you know the ACIS system is working. I also, down in the description, I have a very good video explaining the ACIS, or acoustic control induction system, to give it its full name. I pull a whole inlet manifold apart, show you all the components and how it works. So I would recommend going down in there. There is a bunch of videos in there from also how to install this injector ACIS harness as well. So that would be very useful for you. But we've got things about how fuel pumps work, etc. So I do advise to get down there, take a look, and you have a load of videos that will help you out there. Okay, so that is the injector harness. Now, the next one is what I call the sub. I actually label it the sub. Basically, that goes underneath the inlet and it goes to the starter and the knock sensor. So I'm going to cut to a photo now. You can see it goes in, then it goes to the starter motor, then it goes to knock 1, and then it goes to knock 2. Okay, right, so that's groovy. You can see everything is labeled underneath there. And again, we're working on the fact that this is bank 1, that is bank 2. So knock 1 goes here and knock 2 goes there. Okay. Right, so those are those two harnesses over there. So next up is going to be our gearbox sub harness. So you can see I've got selector, I've got SPD, and this one should be labeled as solenoid. That harness then attaches to this one down here, which is your entire gearbox harness. So again, you've got your NCO speed sensor. This is the one at the front of the gearbox on the left bank side. Then it goes over to your selector. So again, this is labeled as selector. So this is the one we're going to be using to be testing all the gear positions on there. All right. Then it goes further down there, breaks out there, and you end up with your solenoid plug, which is over there, and obviously your SP2. So this is your output speed sensor, and these are all just for the ECU's case. Okay. Now, as I said, this is a universal harness. So in other words, whenever you buy a 3UZ harness from us from now on, this is the base harness that you're going to be getting, with all the standard sub harnesses for all the standard sensors if you're using the standard ECU. But this means that now if you're using a manual, you just don't get this harness over here. You get blanking plugs, but you also have the ability to add a reverse switch and a speed sensor if you so require, and those wires will then come out over here. We've already taken care of the 12 volt for the reverse lights. That's no problem at all. So we just give you a wire that you can take directly to your reverse lights from there, and 2 wires for a speed sensor. You can also opt just to have these plugs blanked off, not a problem at all. And also this plug on the fuse box will change if you're running a manual, because a lot of these are to do with the automatic, which we'll go through when we go through the wires over there. Okay. Right, and lastly, coming out the bottom here is going to be your ground wire. So you can see it's labeled ground there. It just goes onto the M6 bolt over there. And this is the only earth in the harness, so all of it just goes straight into there. One bolt, nice and easy, nothing too complicated there. Right, let's make our way over to the other side now, and we will carry on the other side there. So, as you can see, the harness just runs along here. I'm just using P-clamps on standard mounting points there to hold it in place. But it breaks out here and it goes to, funny enough, ignition left, which will be labeled in there. Again, exactly the same as the other side. There's all your coils. Again, you can unplug that, remove all your coils without having to actually unplug each one individually. You can also swap these out if you go with an aftermarket ECU and want to change your coils. Right. As you can see, the harness runs along there. Another breakout point over there, and it goes to the right bank cam sensor. And this one should be labeled as VVR. There you go, you can see there VVR, so it's variable valve timing right bank. And so that's that one over there, nice and simple. The harness then runs along there, and we have another breakout at the front, and there's quite a bit going on here, so we'll start with the easy stuff. So first of all, we've got our coolant temp, and that goes directly onto there. That's your 2-wire sensor over there. Tucked away at the bottom there, that is our throttle harness. So again, we've put this on a sub harness because you can use either a 5-speed or a 6-speed if you're using the standard ECU. If you're using an aftermarket, obviously you can, but as we're aware, obviously there's some different settings, especially with link, if you're using the 2 different throttles, so to be set up in a different way. With standard ECU, no problem, you can swap that out and you can plug it straight in. So in this case, you can see we've got the 5-speed throttle on here. So we've got our 2-pin motor plug over there, and that will also be labeled as drive-by-wire. That's a label that says throttle on it over there. And unlike the other harness where I took it over the top, I've taken this one underneath to show you what that looks like. And again, that goes over to the TPS. So that's the TPS sensor for the throttle and the motor plug at the top there. All right. Okay, also coming out of here is a wire labeled temp, and that's this long loose wire over here with no terminal on. And basically we give you that wire. It comes out via the fuse box over there, so it allows you to fit whatever temperature sensor you require for your gauges, whether it be an aftermarket gauge, whether you be doing a swap into another vehicle and they had a coolant temp sensor. Now, if you look down here, you'll see I've actually fitted a 3UZ non-VVT-i gauge temp sensor. So it's a single wire one. That screws directly in. So if you've got a gauge that can be calibrated, obviously you can use that and it's a nice straight fit. If not, you can use that hole because you will have a blanking bolt there, not a sensor. Take that out and then you will be able to put whatever sensor you want in there. And you read in the coolant right next to where the ECU is, pretty accurate. Okay. Next up out of here is the oil control valve for the right bank. So again, that just plugs directly in there. This section coming out over here is coming along and it is going to your mass airflow sensor. There you go, all nicely labeled for you. Then coming down here, we then run along down here until we break out over here, and we're going to break out into 2 sections. One is going to be for the alternator. So let me see if I can get that around. There you go, alternator. You can see it mostly there. So in this case, 3UZ 5-speed, we're using the 3-pin, what I call the oval plug over there. But again, if you can't get your hands on one of those, but you can get your hands on one of the either big round ones from a non-VVT-i or one of the 4-pin ones from the next generation 3UZ, specifically the LS and the GS. The only one to be wary of with those 4 pins, and Calvin did a good video as well, but the 4 pins for the LS and the GS actually only use 3 wires out of the 4. The other one's blank. So those regulator rectifiers that are inside there only require the same signals that are in this one over here. So they're really easy to work with. But as far as I've come across so far, the crown for the 3UZ 6-speed, that one actually uses all 4 wires and it is controlled via the ECU. So that one is not advised to be used because we cannot make it work with these particular wires over here. Right, and then lastly, coming down over there, you'll see we've got our O2 sensor over there, which again is a little bracket that you plug in over there, and there's the O2 sensor. So as you can see, we're only using the primary Lambda sensors, not the secondary Lambda sensors. They have been mapped out of the ECU as part of the remap process. Right, so that is the entire harness, really straightforward. As again, like I said, this is going to be the new one. So as you can see now, whatever you buy from us will work for an auto or a manual. I started doing that in the hope that maybe we can try and keep some of these on the shelf ready to go for people. Usually they send us our old harness and we pull the connectors off, clean them up in the ultrasonic and use them again. So we can hopefully try and build a harness like this, just with all the terminals put on. And when you guys send us your old harness, we'll salvage your connectors. and just put it all together, and that should reduce the build times for these harnesses. So again, that is a added benefit. You guys can hopefully get your harnesses quicker than we do at the moment, but we'll see how it goes. But yeah, so hopefully you guys do like that. If you have any comments, please feel free to comment down below. Let me know exactly what you guys think. Right, so that's the layout of the harness. Let's start looking at those fuse box connectors. So there are 2 connectors. And as you can see here, I've got our 9-pin plug, and over there, I've got our 12-pin plug. The 9-pin plug is pretty standard across the board. So if you've seen it in other videos, this is going to be very repetitive. But for the customer, we're going to go through each and every single one so they know exactly what to do. So first of all, pin number 1 is red. It's a big 14-gauge wire. It's this one over here. Obviously, I've got the power going in for the testing, but that is a permanent 12-volt supply. So that just needs to be taken straight to your battery. Now, that does need to be a permanent 12-volt supply when you're using a standard ECU. The reason is the ECU requires a permanent 12-volt supply to retain memory of things like long-term fuel trims and diagnostic codes, etc. If you connect that red wire to an ignition source, every time you turn the key off, you're going to reset the ECU, and you're wondering, why is that a bad thing? Well, what happens is if you do have any codes, every time you turn the key off, it's going to reset the ECU. So if you turn it back on again, you wipe all the codes out, because the second you cut power to the ECU, all the codes are erased. And if you're trying to do diagnosis, that is incredibly frustrating because you cannot get to recreate the code again and again, okay? So again, please guys, permanent 12-volt supply. We do that for a reason. It's not just for nothing. Right, so that's number 1. Number 2 is black with a yellow, and that is our start signal. So you can see the black with the yellow over there. Basically, just requires a 12 volt, so you can get that from your key barrel if you're using a start button. Ignition 12 volts on the other side of the start button, and our black with a yellow tracer wire to the other side of the start button, and there you go. Now again, this is an auto harness, so it is designed to work with the park neutral switch. So when we do the testing, you're going to see that I actually test that it only starts when it's in park or neutral as well. Next up is number 3. That's going to be yellow-green. So that's this one you see over there, and that is for the gauge temp, or I call it gauge temp, and that's in relation to this one over here. So that's where this wire comes out, okay? I put it into my little device so I can see coolant temp on the dash, and that tells me that it is connected correctly, because as I run the engine, it obviously does climb, so I know it's working 100%. Next up is number 4, and that's the gray wire. In this case, I use a 16 gauge wire. You can use a 16, 14 gauge wire, whichever you decide is best. That is coming from the fuse box. That is a 12 volt supply, so you can run that directly to the positive side of your fuel pump. It is using a relay capable of 30 amps, and it is fused at 20 amps because that's the majority of fuel pumps. If you're pulling more than 20 amps, either your fuel pump's probably on the way out, or you've got a blockage or something along the way there. So again, that should be perfectly adequate for 90% of setups. If you require more power than 30 amps or 20 amps, by all means, feel free just to use that gray wire as a trigger to another relay at the back by the fuel pump, all right? And again, the fuel pump is controlled via the ECU. Again, in the description down below, I've got a video explaining how the fuel pump system works for Toyota and Lexus. I do advise going to watch that because people get caught up by the fact that these do not prime the fuel pump when you put the ignition on, all right? Number 5 is going to be yellow with a red, and that's your check engine light. So you can see my yellow with the red wire over there, and that's going again into my cluster to show me where the check engine light is working. What you'll also notice is we've got a little LED in the fuse box, and that's also a check engine light. So I know some guys are very keen to get their engine started to make sure everything is okay before they fit it in the vehicle. So we put it in there for you guys so you can, again, exactly like I've done over here, wire up those 4 few wires, and you can get the whole thing to start on the bench before you put it in the car if you want to make sure everything is okay. Right, check engine light, that also gives a ground, just so you are aware. So if you are fitting your own little LEDs in the dash, obviously you need ignition 12 volts on the one side of the check engine light, and then you take our yellow with the red tracer wire to the ground side of the LED on there, okay? Next up is number 6, which is going to be tacho, and it's yellow, sorry. So the yellow wire you can see over there, and that goes, again, it's going into our cluster so that obviously we can see that we get a rev counter signal. Now, do be aware, when I do the testing, that's looking for a 6-cylinder signal. 3UZs and 1UZ VVT-i, 3UZ VVT-i, and 1UZ non-VVT-i, they all give out a 4-cylinder signal, okay? So it's something to keep in mind as well if you are using like aftermarket gauges. Make sure that it has the option to use 4, 6, and 8-cylinder, and not just for 8-cylinder. Otherwise, you're going to read incorrectly, effectively half of what you should do. All right. Next up is number 7, and that's going to be black with a red tracer. That's going to be this one over here. You can see my finger there, and that is your ignition wire. So that is basically your ignition 12 volts to turn on the whole system. Now, if you are using a key barrel to get that particular signal, word of advice, key barrels have an accessory and an ignition feed. The problem is the accessory feed cuts power when the keys move to the start position, okay? So if you are looking for the ignition feed at the back of your barrel, make sure you find a 12 volt wire that turns on with the ignition on, but also make sure the 12 volts doesn't go away when you move the key to the start position. If it does, you've got accessory, not ignition. It's super important, and people connect it to that more often than you think. What's frustrating about it is that basically what happens is when you go to the start position, you cut the power to the whole fuse box, you shut the ECU down, but obviously the engine still cranks because the starter relay just goes straight through there. So what basically happens is you end up in a situation where the starter keeps on kicking, and then obviously when you let go of the key, the 12 volt comes back again. So you go crank it, nothing happens. You let go of the key, you look over, you see the LED light on, you think, what's going on? Everything is perfect. You're going around testing 12 volts with injectors and coils, and you're like, no, everything is 100%. But yeah, so that's where the frustration comes in. It's very difficult to diagnose, so just make sure that you have the right ignition 12 volts. And obviously if you're using your own switch, well then you're in control of that, so you can make sure that it's a 12 volt ignition supply. Next up is number 8, and that is a pink with a blue wire, and that one is coming just over there. You can see it over there, and that is the alternator light, charge light, battery light. You say potato, I say potato, many names for the same thing. So basically that gives out a ground supply, and we've got to connect it to our device there so we can have the charge light appear on our dash over there to make sure that that is working. Now then, I found this a lot on older vehicles, not so much on newer vehicles, but it is important to mention. If you are using a dash from an older vehicle that uses incandescent bulbs, or like normal bulbs, and you're connecting that pink with a blue wire directly to your cluster, you need to make sure one of two things. I've seen the old clusters backfeed in, and I've seen them backfeed in to the fuse box, keep the whole system alive, even though you switch the key off, okay? Because obviously the signals to the alternator include both a permanent 12 volt supply, an ignition 12 volt supply, and the light. So if you have an older dash, just be on the safe side, two things. Number one, if you have the luxury of getting LED bulb replacements, that is the best solution. It's nice, it's easy, it's quick. And as you can imagine, an LED is a light emitting diode. So what it'll do is it will stop the backfeed into the system. If you can't get that, then just fit a diode into the wire so that obviously you can't backfeed current into there as well. Okay, so that's the solution for that particular problem. Like I said, newer vehicles, it doesn't tend to be a problem. It seems to be the older vehicles that give us issues in that regard. Right, number 9 is yellow with a black, and that is oil pressure. And obviously that is just for your oil pressure light on your dash. It's where this switch goes to. Now, do remember, both the alternator light and the oil pressure light have nothing to do with the ECU. They go directly to the fuse box, and they come out at those particular plugs over there. So there's no harm to your ECU on whenever you connect them. There's not really much you can do apart from shorting out whatever you connect it to, basically. But nothing's going to happen to the ECU. Okay. Right, so that is the 9-pin plug. So moving on to the 12-pin plug now. So you can see pin 1, 4, 7, and 10. They are just the OBD2 connector. So you can see the OBD2 connector there, and that's the top row of that plug. So no need to worry about that. There's nothing for you guys to do there. Pin number 2 is going to be white with a blue, and that is this one you see here, and that is your brake switch. Now, the Toyota ECUs require what would be a 4-wire brake switch. So basically the ECU wants to know when the brake is not pressed and when it's pressed. We've taken care of that with a relay in the fuse box for you. So all you guys are to do is required to supply 12 volts to that white with the blue wire. That will then switch the signals between either the brake being pressed or not pressed in the correct manner. Right. The signal going to the ECU is actually through a fuse. That one is just going to trigger the relay. So again, you cannot do any damage to the ECU with that brake switch connection. So you do not need to worry about that. And you can either get it from your brake switch if your vehicle runs the 12 volts through the brake switch. If not, find the wire that supplies the 12 volts to the actual brake lights themselves, and then tap that wire in. Right. Next up, number 3 is going to be orange, and that is 2. And what I mean by 2 is that's going to supply 12 volts. When the gearbox selector is in position 2, second gear. So you got park, reverse, neutral, drive, and then it goes sideways to 4, then it goes 3, then it goes 2, then it goes sideways to L. So 2, that's where that is. And I'm going to get into a minute why we supply that to you. All right. Number 5 is red with a yellow. So you can see red with a yellow over there. And that is a CCS or cruise control switch. Now, because this is utilizing the automatic gearbox, the ECU has a speed signal from the back of the gearbox. Therefore, we can utilize the cruise control. Easiest way to do it is to get yourself a cruise control switch from sort of early 2000s Toyotas. They all work. They're super simple to install. You basically, one side is a ground and the other side goes to our red with a yellow wire. It is literally as simple as that, and it'll work exactly the same as it did in any other Lexus vehicle. Right, next up is number 6, which is going to be solid yellow, and that is going to be drive. So again, you can see the solid yellow one just over there. And again, that is basically supplying 12 volts when the vehicle is in drive, or should I say the gear selector position is in drive. All right, I'm going to go through in a minute why we supply you with that, but I'm just going to go through them first. Number 8 is black with a red, and that is a reverse switch. So there is black with a red over there. So that's the one you can run to your reverse lights to power them up. Obviously, it will supply 12 volts when the gearbox selector is in the reverse position. And obviously, that's what you're going to use for your reverse lights. Now, don't get it confused with this. This is a completely separate system. This one will not work to give you your reverse lights if you're using the automatic gearbox. Please be aware of that. That's why I've labeled that manual. It only works with manual setups, not the auto setups. Okay. Next up is number 9, and that's red, and that's going to be L. Right, so that is low. So as I said to you earlier, if you look at the shifter on an LS430 or any sort of 3UZ-FE 5-speed, park, reverse, neutral, drive, then it goes sideways to 4, then it goes down 3, and then 2, and then sideways to L. So basically the 4 and the L are not actual positions on the gear stick, they are electronic signals to the ECU. All right, do remember, obviously, it works like all the standards. So if you go from drive over to 4, it basically will go 1, 2, 3, 4, but it won't go into 5th or overdrive. Remember, the 5-speed gearboxes, 4th is 1 to 1, so that's your drive. 5th is overdrive, and obviously that's 0.7 something. About the same between the 5-speed and the 4-speed autos. Anyway, sidetracked. That is how you're going to put the put the ECU into L mode or first gear, and I'm going to go through and explain that in a second. Then next up is number 11. That is a pink with a blue. So that is the pink with the blue over there. And that is your kick down switch. So that is, again, only applicable to European models. So in this case, this is from Australia. This is actually not going to apply to that one. But obviously, we make a generic plug. So George, don't worry about the kick down switch. It doesn't apply to you at all. Lastly, number 12 is yellow with a black, and that is number 4. So you can see my yellow with a black over there. And again, exactly the same as the L. It's the electronic signal that's required to put the ECU into 4, or 4th gear if you want to call it that, but it's not like that. It'll still go 1, 2, 3, 4. It just only goes to 4 and doesn't go above it. Right, so let's do an explanation of exactly why we give you those particular wires. Okay, so the way that Toyota do it, it's quite a nice simple system, and we've just replicated that. So the reason you have drive and 2 in there is so you can use those to supply 4 and L. So remember, the way the ECU works is effectively when you go down to 2 and you push the gearbox selector over to L, just remember that what's basically happening is 2 is still getting 12 volts of the ECU, but then what happens is so does L. So when I actually show you on here, on the cluster, when we do the gearbox auto wiring test, you'll actually see that when I put it into 2 and I touch the L wire, which obviously is the red, and I touch it over to the 2 wire, which is orange, you'll see that 2 disappears off the cluster and then L lights up. So even though 2 is getting 12 volts of the ECU and L is getting 12 volts of the ECU knows that that means it's in L, okay? Now, the reason I'm supplying you 2 to do that is if in a mega rush, you move the gearbox, you moved your selector from 2 up to 3. Now, if you were using switches and I said to you, okay, well, just put ignition 12 volts the other side and do that, what would end up happening is your ECU would have L and 3 having 12 volts at the same time. If I give you 2 and I tell you to run that to one side of a switch, and I give you L and I say run it to the other side of the switch, and if you put the gearbox down into 2 and you flick that switch, it'll go into L. And obviously, if you were to move the gear selector up into 3 without thinking, L is also going to be cut having power. And if you look at the way the Toyota do it, actually to the shifter inside the vehicle, drive and 2 12-volt supplies go to the shifter, and they're then used to output the 4 and the L back to the ECU. So again, we're just replicating that system in its entirety in this particular case. So if you have an LS430 shifter, you'll need those wires anyway, because that's how that works. If you're not using a shifter and you've got your own custom shifter, but you still want to have the 4 and the L as an option, you can use buttons, and then you can take D, run it through a switch, and the other side goes to 4. You can take 2, and then the other side of the switch goes to L, okay? And that way, if you do move the gear position, obviously then you will not get the wrong signals at the wrong time to the ECU. Doing that will take care of that little issue. Sorry, I know it's a long explanation, but obviously it's useful for you guys to know. Okay. Right, so that is the auto gearbox plug, as I like to call it. Obviously, we have a manual version without all those wires like 2 and L and all of that type of jazz in for you guys as well. Right, so that is the layout. That is the plugs over there. Obviously, it's quite an extensive explanation of the plugs. It always is with the auto. So what I'm going to do now is I'm going to get everything set up, and we're going to come back and we're going to start doing the testing, which is a much more exciting part. So bear with me a second, and I'll be with you now. Right guys, so now we're going to jump into the testing of the harness. And as I said, 2 sections, one with the ignition on and one with the engine running. So first thing I'm going to do is I'm going to go through the whole list of what we're going to be testing. Then what I'm going to do is jump into the testing with the ignition on. We'll let the engine warm up for a bit, and we'll move into the testing with the engine running. So with the ignition on testing, first thing we're looking at is the check engine light. So what I want to check is that the light in the fuse box is working, and we get the check engine light appearing on the cluster over there. Next up is going to be the charge light and the oil pressure light. So again, I just want them to come up on the cluster here. There's our battery light over there, and our oil light will be down here in the corner. Once we've done that, then we're going to go look at the OBD2 machine or the Toyota Intelligent Tester. Make sure it's communicating, make sure we're getting live data through there. And then as the fuel pump is being controlled by the ECU, I'm going to use the OBD2 machine there to test the fuel pump, because I can turn it on and off via the OBD tool. Then what we're going to do is we're going to test the brake switch. So I'm going to get the live data on there. We're going to go to stoplight switch. I'm going to touch the white with the blue to 12 volts. And you should see that the stoplight switch will go from off to on and off again as I let it go. Then what we're going to do is we're going to look at the gear selector / shifter wiring. So first thing I'm going to do is I'm going to put the MPX data from the ECU. That's what this little wire is here. This doesn't come with a harness. I'm going to plug it into the dash over there. It'll then give you the gear position down in the corner there, so you can see that. And what I'll do then is I'll go through the selector and make sure that we have all the gear positions and they are working correctly. We'll also then look at 4 and L and make sure that those are working as well. Once we've done that, that's the ignition on testing done, and then we're going to move on to the engine running testing. And first off is the starter circuit. So what I'm going to do, because it's auto, I'm going to make sure that it doesn't start unless it's in park or neutral. That's number 1. Then we're going to move over to the ACIS or acoustic control induction system, and all we wanted to do is make sure that this valve turns down like that. That's literally all we're doing. Then we're going to do the drive-by-wire test. So again, that involves just literally pressing the pedal and making sure that the engine revs up, nice and simple. Then we're going to come back to the OBD2 machine and do the oil control valve test. So that's going to advance and retard the cams. Engine's going to sound incredibly lumpy, but that's exactly what we're looking for. That tells us that the oil control valves are doing their job. Then we're going to test injectors and coils. Now, basically what I mean by that is I'm going to unplug each injector one by one. We're then going to hear each cylinder misfire as I do that. That's going to then tell us that all the injectors and coils are firing as they should do. So we should go from a smooth idle to a misfire as soon as I remove it. The reason I don't remove the coils is because with the 3UZ ECUs, if the ECU picks up a misfire on the coil via the ignition feedback, aka disconnected, it actually shuts down the injector at the same time. So I can't remove all the coils one by one, otherwise eventually I'll kill the engine because all the injectors would technically shut down. So that's the reason why I do the injectors and not the coils. Then we'll come back to the dash and we'll look at our tacho signal over there and make sure that that's working, and I'll give a bit of a rev to make sure that is actually the tacho signal that's coming through. Then we will look at the coolant temp. So you can see right now it is completely flat. Again, after I finish the ignition testing, I'm going to let it warm up a little bit so we can actually see that. And once I've finished all the testing, we'll come back to it and you'll see that it has actually risen up from where it was initially. Then we're going to go and we're going to look at the diagnostics. So we want to make sure that we haven't got any codes that we shouldn't have. Again, because we've removed the secondary lambdas and all of that type of jazz with the remap. We are going to get the codes for the solenoid. So you should have about 7 codes, I think, which is solenoid 1, 2, 3, and 4. And then SLU, SLN, and SLT. But we shouldn't have any other codes. We should only have those ones because the solenoid isn't actually plugged in. Okay. So that's pretty much all we're going to do. So let's jump into the ignition on testing. So I'm just going to put you down here a second on the stand. So just bear with me. It allows me to get the ignition on, and you can obviously see what I'm doing there. So again, black with a red tracer wire, and I'm just supplying that with 12 volts. There you go, nice and simple. So you can hear the relays clicking away there. You can probably hear the drive-by-wire motor humming in the background there, but that's doing exactly what we expect it to. So moving along, check engine light. So you can see we've got the check engine light on the dash, so that's great. And you can see we've got the LED on the fuse box, perfect. Then moving over to the charge and the oil pressure light. Well, you can see the charge light there, you can see the oil pressure light there. So again, super happy with that. Right, so next up, what have we got? We have got the OBD2 test, okay? So you can see here, I've already connected it because it does take absolutely ages. You can see our 7 codes that I was talking about. I'm going to go into function, I'm going to go into system select, and you should see straight away there, it picks it up as an LS430. Perfect. We'll go into the actual ECU itself. We'll take a quick look at the data list, and you'll see that we're actually getting live data through there. So you'll see we're going to have coolant temp 36, intake air 15, throttle position 11, etc. Right, so now we've got that, let's move in and test the fuel pump. So as I said, I'm going to be testing the fuel pump through here. Now it says fuel pump relay and fuel pump. If you watch my video down in the description on how fuel pump systems work with the Lexus and Toyota, you'll know exactly why that is. If not, I advise you go watch that and you can find out. Right, so let's turn on the fuel pump. Right, I'm guessing you can hear that whirring away and turning off, so that's fantastic. So you see the ECU is controlling the fuel pump exactly as we expected to. Super happy with that. Right, so now what we want to do is we want to minimize the amount of data here, because obviously the more data you have, the slower the connection is. So let's get rid of all of this, and we're going to narrow it down just to 3 pieces of data, and that's going to be engine speed, coolant temp, and we're looking for stoplight switch, because that's what we're going to be testing next. So let's pop that into there. Right, so you can see I've got stoplight switch being off at the moment. So all I'm going to do now is I'm going to touch this to 12 volts, the same place that I got from my ignition. And as I do that, you can hear the relay click, and obviously the stoplight turns to on. Let it go, turns off. 12 volts turns on, let it go, turns off. Fantastic, okay. So that is the brake light switch done, and super happy with that. So it's doing exactly what I expected to. So now what I'm going to do is I'm going to swap over the MPX quickly. All you're going to see on the dash is obviously the alternator and oil light are going to disappear, but I'm going to have all my gear positions on there. So bear with me a second while I do that. Again, it's going to be easier trying to do it single-handedly. Right, so... And again, if any of you guys are interested, you only need to connect one MPX. It's a closed circuit system. Right, so now you can see there, it is going a bit crazy, but that's fine because obviously the data's not, MPX data isn't compatible with an IS300 cluster. But what does work is our gear positions, and that's exactly what I want to work there now. So all I'm basically going to be doing is moving the selector as if you were changing gear, and then we're going to see the positions on the dash. So we're in park, we move it 1 click to reverse, 1 click to neutral, 1 click to drive, then 1 click is going to take us past M to 3. Now M is actually 4, by the way, just so that you know when we do the rest of the testing. And then we're going to go on to 2. Right, so that's all the gear positions working. That tells me that all the gear positions from there are going to the ECU and they are correct. Right, so now what we want to do is we want to test the L and the 4. So what I'm going to do now is I'm going to take L, which is red, and I'm going to put it into the orange one, which is 2. So again, 2 should have 12 volts because obviously I've got it on there. So as soon as I touch it on there, you'll see that changes to L. Right. Now, as I said earlier in the layout when I was explaining all the customer plugs, if I now move it from 2 to 3, you'll see L goes away because obviously the 12 volts for the L is being supplied by 2. 2 goes away, that goes away. So I'll get rid of that now quickly. And let's go from 3, we're going to move ourselves up to, other way. Let's move ourselves to drive. So you can see drive is active there. So I know that that signal is there. Now to do 4, which is going to be my yellow with the black, and drive is yellow. So I'm going to take my yellow with the black wire there, and I'm going to push it into the yellow wire over there. And as I do that, let's see if that stays in place. Nope. As I do that, you're going to see that M now becomes active. Now, obviously, as I said to you earlier, with the IS300, it goes from D to M and does like manual mode, so you can shift up and down. That's not on the 3UZ 5-speed models, unfortunately. But anyway, it proves my point, basically, that now I'm in 4. And again, exactly the same. I'm going to move from drive to neutral. Let me go the other way. And you see it go straight from M, which is 4, over to neutral. And if I disconnect the 4 wire now and I go back the other way, there you go. You see I've got drive being connected. So that's absolutely perfect. That's exactly what I want to see. All right. Now then, I'm going to show you guys something that is quite important and I come across quite often. It's the selector switch. It is movable. So you can see that's an elongated hole there. So there's a need a 12 socket on that particular bolt. So it's M8, I presume. Now then, this can be rotated on its axis. So remember, this is the part where the shaft goes through into the gearbox to select the gears. This can be rotated on its axis like that in order to get the selector in the correct position. Now then, on the standard car, everything is designed to work with everything. So obviously it's all perfect. You shouldn't have any issues at all. But even then, they still put the elongated hole so it could be adjusted. Now, what basically happens is, and I'm going to try and show you as best I can, but if I move down to the reverse position, but if I gently wiggle, can you see that? If I gently wiggle it, you can see the reverse just disappears completely. Now there's absolutely no gear position whatsoever, okay? And it does the same on the other side, so I can go to neutral, I can wiggle it a little bit. I think drive works a lot better. There you go. So again, you see now I've got absolutely no gear position, but it is in drive. And if I gently wiggle it, there you go, it came back already just from that. Right, so why is that important? Now, what I would suggest you do is when you are doing the auto versions, use the drive and the 2 as your kind of, and reverse as your kind of indicator to make sure everything is working. So what I suggest normally that you guys do is once everything is fitted, she's ready to drive, stick a multimeter or an LED on that drive wire and put it into drive. Make sure that lights up, first of all, because obviously that's going to tell you that the gear position is working and correct. But number 2, in your own private test track, not on a public road, if I have to say that. Anyway, give it booted, basically. Just floor it, put your foot down and so on. That's going to make the engine tension to the maximum. And if there is any sort of slight movement in that thingy, then it's going to show up. And if it does that, then you can just undo that bolt there, adjust that slightly, tighten it back up again, get in the car, boot it. Until you can boot it and the D stays on 12 volts every single time, okay? So again, probably easier on 2 because it's only going to be first and second gear. Probably a lot easier to do that one. You won't get up so much speed when you boot it. But anyway, if the ECU loses gear position, it does funny things. So just make sure that that is working correctly on your setups when you do your swaps, all right? So that obviously everything works as it should do. Again, you don't need an OBD2 machine for that. I've given you drive 12 volts. So if you put a little LED or your multimeter on there, and you just get a friend to sit with a multimeter in the car and you just boot it. And if drive drops off from 12 volts, then you know something is going on. All right, adjust it, come back again. Right, so that is all the gear selector wiring that we need to do. So that brings us to the end of our ignition on testing. So what I'm going to do now is I'm going to let the engine run for a little bit to warm up so we can look at that coolant temperature gauge, sort out the MPX again so we can get our oil light and our alternator light back. So let me do that and I'll be back in a second. Right guys, so I've let it get up to about 40 degrees so we can start seeing the coolant temperature working on the dash there. So quick recap of what we're going to be doing. Nice and simple, starter circuit, making sure it only starts when in park, ACIS, making sure that that valve goes down after a few seconds after it starts. Drive-by-wire test, we're just going to be pressing the pedal like so to get it to rev up. Then we'll do the oil control valve test with the OBD2 machine, and then we'll do the injectors and coils test, and obviously we'll come back and do the tacho. Look at the coolant temperature, so you can see it's not quite halfway yet, but obviously I've adjusted it so it comes on very quickly. But what I want to see is that needle move slightly higher so I know that it is working. Then we'll come back and we'll talk about the diagnostics on that one. So first thing I want to do is obviously at the moment it's in park. I'm going to move it to reverse. So there's my click. I'm going to take my black with the yellow tracer wire. I'm going to touch it on 12 volts. And you'll see I get absolutely nothing through there at all. I'm going to move it back into park now. Correct way. And 3, 2, 1. Oil line have gone straight out. We still have the check-in light, engine light on for the gearbox codes because the servo mode is not connected, but that's absolutely fine. So let's move over to the ACIS, and that's going to be, so you can see that valve has gone down, so that is absolutely perfect. Right, drive-by-wire test. That's working as it should do. Oil control Right, so let's move over to the injectors and the coils now. So we're going to start here with number 1. So number 1, number 3, number 5, and number 7. So, number 2. Let's see which ones. Oh, it's number 7. There you go. Right, okay, so we did number 2 already. Let's move over to number 4. Number 6 and number 8. There you go. So super happy with that. That means all the injectors and coils are firing as they should. Let's pop over to our tacho. You can see it's working there. Fantastic, happy with that. And then obviously our coolant temp has risen up, so super happy with that. All right. So what I'm going to do now is I'm going to kill the ignition, and we'll come back and we'll look at the diagnosis over there. So kill that out. Put the ignition back on. Let me get rid of my ear defenders. Rightio, so obviously lost communication there. That's absolutely fine. Right, so diagnostics. With these particular models, specifically EU, US, Australian as well by the looks of it, they will only work with a diagnostic machine. You cannot flash the codes by bridging the 2 terminals, so just be aware of that, okay? Now, obviously, on here, I'm going to go into the DTC. You saw we had 7 codes earlier, so basically we're looking for the exact same 7 codes. And so let's go through there. Yep, so we've got all the 7 codes there. So as I said, solenoid 1, 2, 3, 4, SLU, SLN, and SLT. What is important there is obviously we don't have any codes for secondary lambdas. We don't have any codes for any sort of evaporative emission stuff on there. It's all been remapped out, so it is of no concern whatsoever. So as long as the gearbox gets plugged in, and obviously then all of those 7 codes will disappear, check engine light will go out, and you should be able to run it exactly as you expect to. Okay. Now, I did actually include the TC wire, the one that you normally bridge to check the check engine light through the flash codes, okay? But I did include that for a reason, and that is basically there is still something that you can do with that. Now, if you do bridge those 2 terminals, it does still put the ECU into diagnostic mode. And what that does do is it does lock the timing at 10 degrees. So you can see down here, we've got 0, 5, 10, and 15. And if I'm lucky, oh, look at that. I've painted in white my little mark on the crank over there. So if you are under the impression possibly that you have skipped a tooth, or it's moved, or you didn't do the timing correctly when you did a timing belt, rather than pulling everything off and trying to look at all the mechanical timing marks, bridge pin 5 and 13 in there. They're directly above each other with a paper clip or whatever you want to do. Start the engine, grab your timing light, stick it around coil 1. Now, some timing lights do work if you just put the clamp around the wires. Some don't. If not, you have to remove the coil and get an old-fashioned spark lead between the coil and the spark plug and use that. But if you have one like I do, you can just wrap it around the coil wires and then just check that the timings are 10 degrees, okay? Obviously, super important. If you do that, please remove that particular paper clip. Otherwise, you're going to lock the timing at 10 degrees and you're going to have a horrible time because you're going to have no power. All right. So that's the harness done. I've tested it. I'm super happy with it. It seems to be running absolutely fine. So hopefully there's no dramas at all. We've got to get this off to Australia so it can be fitted into the vehicle. But if you guys do have any questions, please let me know. You can send me a message at info@phoenixenginemanagement.com. You can also comment down below and I'll try and get to those as much as I can. We are also on Facebook as well. So we do some posts up there as well as Instagram. So you can find us there as well. But again, if you have any questions, please pop them down below. If you have any opinions on the new thing with making it sort of universal and working both with auto and manuals, again, my train of thought was that some guys buy it with an auto, like in this particular case. And then obviously if you want to sell it to someone with a manual, then it becomes a problem and you have to cut the harness up and you've got to make changes and bridge neutral start switches and all that type of jazz. Whereas now you could buy this for a manual, you get your blanking plugs. If you buy it for an auto, you get your auto gearbox harness. And if you buy it for a manual, you can also get a reverse and a speed sensor, which we didn't previously do. So again, it's another addition into the thingy. So again, the whole idea is twofold. Number one, You can then sell your harness onto a guy that wants to run it with an auto gearbox. You can phone us up. We'll supply the gearbox harness and the correct fuse box plug for the auto. If this guy wants to sell it, somebody wants to run it with a manual, he can phone us up. We'll send him the proper plugs to make it a manual, and we can also create him a plug there for the reverse light and the speed sensor as well. So, like I said, would appreciate you guys' feedback. Obviously, we do things, and it's nice to hear if you guys are either in favor, not in favor, have any other suggestions that you think we might change possibly on it as well. But yeah, fire those comments down below. Let me know what you think. And like I said, if you have any other videos that you'd like, things that possibly you're unsure of, that I can do a video on next time I have that particular setup in the workshop, please feel free to put those suggestions down below. It's a simple case of I don't know what you don't know. So give me some questions. I'll see if I can make a video on it and keep you guys up to date and give you guys loads of information to help you out. But thanks for watching, guys. We'll see you again soon. Bye-bye.